Recently, Snapmaker took the consumer 3D printing world by storm with the Snapmaker U1, a sub $1,000 Ford tool changer that has raised a staggering $16.5 million.
17 already.
That has raised a staggering $17 million on Kickstarter and counting. But how did they actually do it? I mean, what innovative manufacturing techniques are they implementing that have allowed them to come in so much cheaper than even the two nozzle solutions from their competitors? And more importantly, will they actually be able to manufacture so many of these printers before the end of the year? To find out, I flew all the way to Shenzhen and got an exclusive look at how this innovative printer is actually made. Come on, let's get after it. Hey there, and welcome to the assembly line for the Snapmaker U1. We have flown all the way to Shenzhen to check out how they are setting up this assembly line for maximal efficiency. And what I want to show you guys is some of the really interesting techniques, procedures, and strategies that they've used to make such a complex printer at such an incredibly affordable price. Now, the keen-eyed of you will probably notice that there's nobody here. We are here on a Sunday. We needed to come here on a Sunday to film without actually obstructing the assembly line. This is a working factory, and they're still very much engaged in actually perfecting the processes. So they're in the process of getting all the different steps to be absolutely nailed down. They will start production by the time you see this video, around September 15th. But let's go ahead and have a look and see where the steps are and how it's actually gonna look when production starts on September 15th. So all in all, this entire production line is 50 meters and consists of 31 steps. Now, there are a lot of interesting things happening within those 31 steps, and I'm going to point them out as we go along. The first thing I want you to notice is that many of the steps are actually dual-sided. And this is a really, really clever technique. Now, the logical thing when you look at a line like this is you would think one stage, one step. But actually what they've done here is very clever. Each stage is broken down into a right and a left. Because think about it. If I'm working on one side of the printer, the front or the back or the left or the right, the other side is just sitting there. So in the time that I'm working on some part of this printer, my colleague on the other side can be working on the other side of that printer. And that can be doing the other side in the mirror image, if it's that case, or it can be two totally separate parts of the same step. If I'm working on the screen, it can be working on the cables in the back. And that's a really interesting way to increase the productivity. It's probably pretty commonplace in assembly lines like this, but if you've never thought about it or never been in a factory like this, you've never considered that, yeah, that is completely wasted time when the printer's not being worked on the other side. Really cool. All right, in a second, we're gonna get into the actual steps of the production that, real humans do. But I wanna start on step 0 because this machine is one of the coolest things I've ever seen in my life. First off, note how it uses a lot of standard aluminum extrusions in the same way that we use on our 3D printers. It then uses these modular platforms that actually use hydraulics to raise up the platforms and then push them along. And as you'll see, we'll probably show you a time-lapse video of how this works, but it's actually handling the queuing, and it knows so that when things get backed up, they don't cause pressure. The person can, first off, stop the line. Anyone in the line can stop the line. But also, this system is automatically queuing and creating a line when there is certain backups. Now, it's important to note, each one of these 31 steps is designed to take 180 seconds. So an entire printer should move down this line. I think that makes it around 90 minutes. But each step is designed to take roughly the same amount of time, so there shouldn't be a need to fall back on this system's ability to queue and create kind of a waiting line, but it's there in case someone has an issue and needs to. So we've arrived at the first step on the assembly line, and actually it starts with the bottom. You've heard the saying, started from the bottom, now we're here. In this case, we're starting with the injection molded bottom piece of printer on which everything will then be assembled. Now this is a two-step process conducted by one person is much faster and much more skilled than I am. The first part is placing into this jig the entire assembly. Throughout the assembly line, you will notice a lot of these jigs, which are used to quickly locate things so that there's no need to manually position them. You simply place when the jig is affixed. In this specific case, we're going to be putting on the Z motor and using this handy screwdriver, which is on a retractable cable, to actually attach it into the extrusion or the injection molded part. From there, they will flip it over and over here, placing it into another jig where they will take one of these pulleys and stamp it down. One really cool thing I think was the use of pins and these jigs to just make everything so much faster rather than having to do it manually. Slap it in, press it down, you're done. Now you might be wondering, 180 seconds is not a lot of time for a lot of different things to happen. So another cool thing that they've done in this assembly process is some of these jigs actually move. You might have wondered to yourself, wait a minute, if I'm just screwing in the Z motor here, why do I need a jig and why do I have this hydraulic press? Well, actually, after I've screwed in the Z motor, which is available here and near the screws, I can then move the jig, place the pin, and press it down. Oh! I think there's a technique that I don't know. But I think it's really cool that we have these jigs that actually move to make one person able to do so many different steps in 180 seconds. Now, as I said before, I can't show you guys all of the steps, but what I can tell you is you're gonna very quickly notice that it really starts to look like a 3D printer very quickly on in the process. And I don't want you guys to think that it's because we're skipping a lot of steps. That's actually what's happening on the line. And the reason that it happens that way is because they have a system of sub-assemblies. So not all the assembly is happening here. First off, a lot of components come in from other suppliers around the area, the local area. But then on the other side of the factory, which hopefully we'll be able to show you later in the video, they're creating entire sub-assemblies. So for example, at a certain stage here that we're gonna show you in just a second, they're actually putting the entire XY motion system, which has been assembled on an entire sub-assembly line. That way, this worker who has 180 seconds puts it on and that's ready to go. But what I want you to notice here is the second reason that a lot of this comes together very quickly is that you have kind of sub-steps and sub-stations within the station. So a worker here, while the line is moving, once they finish a piece here, is actually gonna come over here and do the prep work on a separate table for an entire next printer. So the prep work is happening while they have already completed this. So I might here be getting ready for putting the pulleys on, getting the belts ready, and then once the printer shows up, I already have the parts ready, boom, to put them on the line and get them ready in that 180 seconds. So here we've got some additional jigs. As you can see, this is a rotating jig, which allows them to quickly assemble a piece of their sub-assembly and work actually here on the bottom of the bed. You can see on the other side here, we have a platform for the bed. And here, this is a jig that allows me to do some parts of the process, flip it over, do some other parts of the process. And these subtables, as I said, are all designed for maximal efficiency, so I can get the parts ready here rather than including that in a part of the step that needs to be done here in that all critical 180 seconds. All right, so we are now at the end of one of the sub-assembly lines, and this is probably the most important sub-assembly line because this is where the XY motion system comes together. As you can see, this is its own entire sub-assembly line with about 21 steps, including a lot of steps that I cannot show you, including the machine that is behind me. But as we get to the end of the line, you're starting to see what this assembly looks like when it heads over to the other side of the factory. So we've got our smooth rods in here. We've got our belt already installed. We've got our carriage piece already installed, and obviously the X and Y motors, not to mention everything is assembled with all of these sheet metal pieces and all of these screws. Now, there's a little bit of magic that happens that also assembles this, and I can't exactly tell you why, but it contributes to the rigidity, strength, and durability of this, and let's just leave it at that.
So this is a pretty interesting thing I noticed. Some of you may know, if you've ever built your own PC, that you should ideally wear a ground bracelet and ground yourself. But where do you do that here? These tables, these assembly tables, are made out of aluminum. They don't conduct electricity. So how do you run the ground? You've got this thick ground wire that everyone taps into, and it runs to the end of the tables, and therefore you can have an easy ground.
Another interesting thing that I noticed is that on this sub-assembly line, you have these padded cloth carriers so as not to scratch certain parts. Whereas on the other part, if you're not as concerned, you need the turntables, you have the turntables. So each sub-assembly line can be configured for what's going to be on it. And there's different types of rollers, or some of them don't even have rollers at all. Some of them are just solid surfaces. All right, we're now at the end of another one of these sub-assembly lines, and we're not going to show you every single one of them because this video would be many hours if we did, but I wanted to show you guys an example of one sub-assembly line which doesn't need the actual rollers or conveyor belt. It's doing something relatively lightweight, and so normal tables are used. In this case, we're looking at an almost fully assembled heat bed. Now, by this point, someone has already used a machine which automatically injects the perfect amount of glue into these channels, which then allows you to put in the heating element without there being too much glue to come back up and overflow through the channels. And there's a second type of glue which is going to affix it in more solidly, I guess. At this point, all that's left to do, with all the wiring done and all the different steps, as you can see, have already happened, all we need to do is add on this cosmetic cover, which I believe these wires need to go through here, snap it into place, and screw everything into place. Again, using this guy. At that point, the heat bed is also fully assembled, and it is going to go over to the main assembly line with all the other sub-assemblies to be added in at the right time. Now, I was talking to Wushu, who is the head of R&D and product development here at Snapmaker, and I want to give you guys an idea of just the level of thought and meticulous, deliberate decision-making that has gone into making this line as efficient as possible. Each one of these sub-assembly lines that I've shown you directly corresponds to that stage at the main assembly line. In other words, what is finished here does not go to the beginning of the line. It is going to go directly over here at this point on the line. Now, obviously, there might be a meter here or a meter there, but what ultimately that gives them is the ability that when this person at this point on the line runs out of sub-assemblies, they don't now need to cross the factory and potentially slow down the entire line. They need to take the minimum amount of steps to come over here to their colleague who now has the appropriate sub-assembly that they need, pick it up, and get back on the line so that production keeps flowing. You guys get your orders as fast as possible.
So yeah, what did I tell you guys? Very quickly, it starts to look like a bare bones entry-level printer, perhaps from another competitor. But this is just one stage on the process. Let's stop and observe, because we did have to skip some steps, and see just what we're dealing with. At this point, we already have smooth rods. We have lead screws here. The bottom should be all belted up, and we have basically an entire Z motion system here. Additionally, as I said, that sub-assembly of the XY motion system has already come in fully assembled from over there and been placed on top. We even have the carbon rods and the carriage. So this thing is basically ready to move if only it had electronics. All the actual motion components and structural components are already in here, and you can see it is ready to start getting the electronics and things that make it a printer. Now you might be wondering, this is one of the few stations here which I don't have a substation or another table to work on. So what's actually happening here? Interestingly enough, these screws will arrive here, but they'll arrive loose, which is why I don't need any screws here. That other step where they've actually assembled the Z and put the motion access in 180 seconds, they're not going to be tightening all those screws. So here, this worker is going to be tightening all the screws that actually make these sheet metal pieces affixed to the printer, and then it's ready to push along. So although it has come together very, very quickly and it's already starting to look like a 3D printer, we're only about 30% of the way through the line. At this point, some adhesives are added and there's some magic to this process where UV is used as an additional way to affix certain parts of the frame, which we can't talk about. But now we're starting to get into some of the more granular and finite pieces. Over here, we're going to be adding just small screws and pieces for different components of the motion system. Here you can see we're starting to add in some early wiring harnesses and some lubrication. I do think it's pretty interesting that someone here is working on two totally different parts. So obviously what the process designers have figured out is, hey, adding in this particular wiring harness, which has to go in before other steps, that's only taking this person 25 seconds. Let's give them something else to do, which is not going to interfere with other parts of the process. For example, lubrication. So they're really leveraging as much as they can of that 180 seconds to ensure that each worker is doing as much possible work on each printer as they can in 180 seconds, while simultaneously not interrupting or putting things that will slow down the other parts of the process. And again, I want to remind you guys that a lot of this stuff is happening on both sides. I'm taking you through the right side of the assembly, but each one of these steps is going to have a complementary step on the left side. Or for example, when I show you this wiring harness going in, well, the immediate next step that's going to happen is going to be the power supply going in over there. And then the next wiring harness that is going to go in is going in over there. So now that we have so much of the electronics in, the power supply and some of the wiring harnesses, it's time to start putting the first cosmetic panels on, starting with the inside. So we'll start taking these panels and placing them in. There we go. A lot faster than that. Moving on from here, we're now moving from about 50% on the line downward. Now, I've been told a lot of this is secret sauce that they don't really want shared. So I'm going to share with you the broader strokes. We can see a few injection molded parts going in here, a lot of AC wiring going in here. And then we're starting to see over there more of the electronics and wiring that have not already been put in start to come in. Here we've got different stages of Loctite, fixing fasteners and things like that. We're now arriving towards the last 20% of the line, and we still don't have any tool head or carriage. We have a motion system, we have electronics. The entire thing is ready to move, but it doesn't yet have printers. Now the U1 obviously is a tool changer. That's what makes it special. And each one of those tools is going to be a perfect example of one of those sub-assemblies we talked about that are created on the other side of the factory and then brought in at later stages. But before we assemble that, we need to start getting the carriage assembly, which is going to pick up each one of those tool heads assembled. Here you can see that is an example of one of the sub-steps on the main assembly line. And the worker here is going to start assembling this by putting a fan into the tool head carriage, by adding in various little CNC parts and screws, putting in some Loctite, all in that 180 seconds again, so that they are now ready to put it onto the printer, so that the next hobby can hopefully get some tool heads fully assembled, added on to the printer. But before we actually get those tool heads added on, we need to finish the rest of the cosmetics. You see, because the U1 is open on top, at least until they release that optional top hat, we can actually close up the other sides of the printer with the glass door, as well as the additional cosmetic panels, and then later the tool heads can be actually added from the top. So we have two of these panels, which already will have the RFID detection sensor, again, sub-assembly. Those will be plugged in, which I'm not going to do. And then they'll just be right in, pressed in place. It's actually done by two people on each side, so they don't have to rotate the printer. And I've got plenty of time. I've got time for a cigarette break here. That was only like 10 seconds.
Look at this view. This is where you take break time. If you work at the Snapmaker factory, just come out here, catch some fresh air, look at the beautiful fields, mountains. It's amazing. It's gorgeous here.
At this point, we're about 90% of the way through the entire process. It's actually been an incredible world. You can see here, we're now ready to add some rubber grommets here and put on the final cosmetic piece. At this stage, we're also seeing the tool heads going on. We're not going to show how that gets done, but only after these parts are almost fully assembled do we start to see the tool heads going on. Once the tool heads have gone on the printer, we got to connect them with PTFE tubes.
And there we have it, a fully assembled Snapmaker U1 with even the filament holders. And I bet you're wondering, Jonathan, why do they have the PTFE tubes and the USB connectors and the filament holders, but my printer, when I get it at home, doesn't have those parts assembled? I had to assemble them myself. Well, that's because we're now getting into quality control and testing.
Obviously, the Snapmaker U1 is a pretty complicated machine. There are quite literally a lot of moving parts. And so before every single machine gets boxed up, it is fully assembled, including all the things that you will be assembling when you get it at home. And then it goes through a litany of tests. Those include 2 hours of non-printing tests, as well as 10 hours of actual printing. So here you can see we have racks and racks and racks of about 150 printers being tested concurrently at any given time. And they're doing pretty complex tests. We'll show you guys some of the test prints that they're doing. This is not just a let's extrude a bench sheet, but they're testing multicolor. They're testing the pogo pins. They're testing the motion system, the quality of the extrusion, and much, much more to ensure that when you get your printer home and reassemble it, it's going to print perfectly.
This is pretty groundbreaking stuff for consumer 3D printing. And as you can tell, a lot of bold and courageous decisions have gone into making this printer. Really makes you think that it must have taken some massive balls of steel. Ah, here they are.
So that's just about everything I can show you of the U1 production line. Obviously, I've tried to show you guys as much of the manufacturing process as possible, while still having the factory closed because it is a Sunday here and we weren't able to film when the factory was actually operating, and B, still maintaining the trade secrets that Snapmaker really wants to keep under wraps. As far as updates go, factory is going to be in full production starting September 15th. If you want to pick up a Snapmaker U1, you still can, depending on when you're watching this video. Pre-orders will still be happening either on Kickstarter or on Snapmaker's website. One way or another, there is going to be a discount, although it will not be the same as the Kickstarter discount. There should still be a discount offer available, and I'll put a link down in the description if you want to check that out. Using our link does support the channel. It also lets sponsors like Snapmaker know that you want to see more amazing content like this. Hey, I hope you guys learned something. I would really love to know in the comments below what you found to be the most interesting part of this tour, and if you'd like to see more tours like this in the future. I'm always itching for another opportunity to make my way over to Shenzhen. So thanks for watching, and I'll see all of you on the next layer.